Hello everyone, welcome back to Discrete Mathematics. We are still discussing bipartite graph. We are solving this exercise, so if you're done then we could continue, but otherwise pause the video and try solving this first. Alright, so here is the solution. So the first question is the three-dimensional hypercube Q3 bipartite? So what is the solution? Well, remember Q3 would look like this, right? So let me just draw Q3. Q3 consists of, the nodes of Q3 is bit string of length 3. So like this. And 0, 0, 1, and then 0, 1, 0, 1, 0, 0, and there is an edge here, an edge there, an edge there, and then there is a node 0, 1, 1, and you have connection here, and then there is a node 1, 0, 1, you have an edge there, an edge there, and there is a node 1, 1, 1, and of course 1, 1, 0, right? So 1, 1, 0, 1, 0, like this, right? Looks like a cube, right? So is this graph bipartite? Well, one way to solve this is simply assigning colors. So one color represents one part of the partition. So let's use the color blue. Yeah, blue and red, right? So this is blue, this is blue. Yeah, if this is blue, then the neighbor has to be red. Yeah, this is red. And then assign the neighbor of red to be blue. This has to be blue, so this is blue, and the neighbor here to be red. So that's, now if we could make this coloring, then the graph is bipartite. So if you could use two colors this way, then the graph is bipartite. But if, for example, you want to assign these colors and suddenly you get a conflict because a node turns out to be it turns out that one node needs to be colored in two colors, so different colors, then we cannot have a bipartition. So so in this case, the v1 is 0, 0, 0, 1, 0, 1, and 1, 1, 0, and 1, yeah, yes, sorry, forgot one node. So 0, 0, 0, 0, 1, 1, 1, 1, 0, and 1, 0, 1, and then v2 contains 0, 1, 0, and 0, 0, 1, and 0, 1, 0, 0, and 1, 1, 1. Yeah, so, and then the edges connect only a pair from these two. So this is a bipartition. So yes, the answer is yes. So what about n-dimensional hypercubes generally? Remember, n-dimensional hypercube will have the set of phi will consist phi contains phi contains 2 to the power of n bit strings of length n. Now, and then of course A and B are adjacent if and only if, well, of course, if A and B differ in 1 bit position. Yeah, exactly 1 bit position. Exactly 1 bit position. So now this is general N. All right. So can we determine using only this information that whether the graph is bipartite or not? Well, if you look at Q3, you could actually arrange the nodes this way. So 0, 0, 0, and then you have 0, 0, 1, 0, 1, 0, and then 1, 0, 0, and then you have uh, 0, 1, 1, 1, 0, 1, and then 1, 1, 0, then 1, 1, 1, where you have an edge this way, and this, yeah, and this, and this, and this, and then also this, and this, and then you have this. Now you see, for example, this is in this level you have this many. Here you have, so 3, 0, 3, 1, combination of 3, 2, and here 3, 3. Now apparently if we have n-dimensional hypercube, then you could arrange the nodes this way. So up to n, right? Length n. Yeah, and then you have or so let me just do it here. So for Qn, yeah, it will have n taking 0 nodes, bit string with 0 bit 1, and then n1 bit strings with 1 bit 1, and a combination of n2 bit strings with 2 bit 1, and so on up to nn bit strings with n bit 1s. Yeah, so now these are the nodes, and the edges only connects from here, from these nodes to the next one, here to here, and so on, right? So with this we could simply assign this is red, this is green, this is red, this is green, and so on, and you could do that very easily. So therefore the partition of Qn will be partitioned into V1, which consists of bit string x such that x has an even number of bit 1s, and the other part is x such that x has an odd number of bit 1s. And you could check that an edge would connect only nodes between V1 and V2. Yeah, because this is our pattern. Yeah, so yes, The answer is also yes. Yeah, so that's the answer for the exercise, and then we will talk about matching in the next part of in the next video.